I think now the recording is started. Okay, good evening, everyone. Thanks for joining. This week, the topic is a little bit complex, and Elena has also posted an example, and I have also posted an example, and I just wanted to make sure you guys have understood the topic normalization, and this pretty subject would be extensively tested for the midterm. I want to recap the midterm. Midterm is 100%. You have 50 points for Part A and 50 points for Part B. Part A would be multiple choice questions, and Part B will be scenario type. I would give a scenario, okay, here is it, resolve it based upon what you learn. Even Part A, it is the application of the concepts. It's not straight from the book. So I would give you a concept, I would give you options, you need to understand, you need to make sure you apply what you have learned to identify which fits the closest category for the question what is being asked. Okay. Then let's move on with the normalization. This web should not take much longer, but I want to give you some hints how to respond to the question of normalization in the exam. Okay. Having said that, I am using the textbook page 180 onwards. Now, why do we need normalization? Normalization is needed to avoid redundancies. Why do redundancies happen? Redundancies happen for various reasons. And how do you find redundancies is what I will show you some examples. When you have some certain anomalies, then that will lead into various type of problems design process. In order to avoid these anomalies, you have to normalize the database. That is the main concept and principles for normalization. Normally, when you create tables, keeping in mind the logical database, you would definitely be able to understand what it is and how it is, and various concepts you could definitely be able to. 1 second. Okay. So various concepts you could definitely. Just to mute, please. Okay. Now let's go back to normalization. I just posted a document, and I will explain what it is, and I have also explained in simple steps. Now, there are three types of anomalies: what delete, update, and insertion anomalies. If you find any kind of an anomaly in your table design, that means there is a room for normalization. So, with this example, I will explain the entire concept of normalization. So, for the exam, for this course, we will only be going over three forms of normalization. You could ignore the fourth and fifth, and also Boy's code normal form. Also, there are concepts with surrogate and higher normal forms. You could ignore that one as well. Normally, we do Boy's code normal form and the other normal forms in 652, and some professors do cover, but it is pretty complex. But in the industry, we leave it to the third normal form. So, for the exam, you can stop with third normal form. We are not going to cover fourth and fifth and Boy's code normal form. Now, if you look into the document I have posted, let me share my screen. Okay, you guys see the document? Yeah?
Yes.
Oh, thank you. Okay, now, how do you do normalization? I will go over this twice. So, hold on for all your questions. Let me go over once. I'll give the opportunity to ask questions, then we go over this second time, still further simplified. Now, let us consider this table. I have shown a table, a student SSN class, offer number, offer year, enrollment grade, course, and course description. This huge table for the university has some kind of anomalies. What is an anomaly? For example, if I want to insert a student S3 into the table, you cannot insert the student alone, but you should also get information about offer number, offer, and all sorts of things, because student SSN offer number is a key. So a prospective student cannot be inserted into this table. And if you look into the values in the table, S1 has 2 rows and S2 has 2 rows. If you want to delete one row in S1, then it will delete both the rows in straightforward SQL if you do without putting a where clause condition. And if you do, that is called as deletion anomaly. When you do an update, you cannot update one row of information because of the structure of the table has been created. When you have certain factors like this, when it causes to stop insertion, update, and deletion, those are called as anomalies. When you find there are anomalies in any table, that means there is room for normalization. That is your first test for normalization. Now, once you know that whatever is given is a candidate for normalization, then you need to create something called a we do something called a functional dependency list or functional dependency diagram. So now let's go back to the table. The first step, when you think there is a room for normalization, then we have to see if there are possibilities of a repeating row of information. For example, in this case, if you look into the first table and the second table, what it shows is the S1 JUN and S2 JUN are repeated. This is called as repeating groups. When you remove the repeating groups of information from the table, then the table is normalized to the first normal form. In other words, if you find a table which has anomalies, then that table is a candidate for normalization. Then if you see there are repeating groups, that means the table does not meet the first normal form. If you eliminate repeating groups, what I have done, that shows that the table meets the first normal form definition. So it's first normal form. Now, in the second normal form, if you want the second normal form definition, so there is something called as functional dependency diagram. You need to create functional dependency diagram. The functional dependency diagrams are created as shown in the illustration. You start with the primary key and the arrows end with the all other columns, which is student SSN. It starts and it points to the others. Then there is an offer number. It identifies other. So based upon this specific functional dependency diagram, you create functional dependency lists. For example, if you see student SSN identifies city and class, that becomes one functional dependency list. Offer number identifies term, year, course number, and course description. That is the second list. And offer number the combination of SSN and offer number identifies the grade. Then course number identifies a description. So this is the meaningful grouping of your columns, which identifies which. They are called as functional dependency lists. Now, how do you define functional dependency list? In simple English, for example, 20904 is a zip code which identifies Silver Spring. So if X identifies Y, X is functionally dependent on Y. So 20904 identifies Silver Spring. So Silver Spring is identified by 20904. That means Y is functionally dependent, X identifies Y. These are called as functional dependencies. So, after we eliminate the repeating group, we create a functional dependency diagram. From functional dependency diagram, you create a functional dependency list. Once we create the functional dependency list, we come to a simple definition of second normal form. See, what is violation rules for the second normal form? If a non-key column depends on all candidate keys, not subset of any candidate key, that means it violates the second normal form. I have given a very simpler, easy way to identify a violation. Now, if you look into the functional dependency list, which has come out from the functional dependency diagram, in this case, course number is identifying course description. Course number is not a key, but it identifies course description. That means there is a violation of the second normal form. What we get the big table, we break it down into three simpler tables. So in this case, the dependency lists are nothing but they are tables. They become entities. So in our case, there should be 4 tables. But since course number identifies course description, that means their non-key identifies another non-key column. That means there's a violation. So that doesn't become, we remove that functional dependency list, and these other 3 dependency lists becomes 3 entities or 3 tables, which meets second normal form. After we finish the second normal form, we go to the third normal form. So the simple definition for third normal form is a non-key column identifies another non-key column. That means it violates the third normal form. In our case, if you look into the second table or the second functional dependency list, offer number identifies term, year, course number, and course description. But if you look in the reality, course number is identifying a course description, which means a non-key column identifies another non-key column. So that is a candidate for third normal form. We have to remove that from there. So if you look at this is how the table becomes. So offer number, whoever is therefore not muted, please. Now offer number identifying term, year, course number, course description is broken down into these 2 dependency lists. Offer number identifies term, year, and course number, and course number identifies course description. So this one functional dependency list is broken down into 2 dependency lists or 2 tables. Now, if you look into this number identifies course description. If you look the underline, when you see something underlined, it is a primary key. So then, when you break down this table into 2 tables, the 2 tables, when you join back, it should give your original table. So, how you can get back the original table? This table and this table should have a common foreign key. So, course number becomes the foreign key in this functional dependency list. So, offer number, offer term, year, and course description, we have to break into 2 tables. So, when we break into these 2 tables, this is how it will look when we. But the rules of normalization are rules of entity relationships. When you make a huge table into simpler tables, you have to get back your original table. How can you get back the original table? You should have a common foreign key. So the course number is a foreign key which links both functional dependency lists. So when you have this relationship, it gives you back your original table. So now when you look into this, so the second functional dependency list becomes like this: offer number, term, year, course number, course number and course description. In reality, the original table is down into 4 tables, which is shown in the final list of tables. Now, after you break down into 4 tables, you need to do validation for normalization. What are the validations? You have to test whether you can insert, whether you can delete, whether you can update without impacting other rows of information in the tables what you have. For example, this is the first table, SSN city class, correct? Our is SSN city class. In this table, whether you can insert, whether you can delete, whether you can update. If you make sure there are no anomalies, then the final list of tables meets the third normal form. So once you come to that step, you can stop it for the normalization problems for the exam. Okay, to summarize, what we do is, if I get a problem for normalization, you have to check whether there are anomalies in the table what I have given. If there are anomalies, then the table is a candidate for normalization. Okay. That's it. If the table has repeating groups, then it fits the first normal form. You have to eliminate the repeating groups to meet the first normal form. After you eliminate the first normal form, you have to create your functional dependency diagram. Once you create a functional dependency diagram, you have to create your functional dependency list by making meaningful group of your column. After you group it, you have to check for second normal violation. So once you identify violation, you have to eliminate the functional dependency list and groups the tables you meaningfully to form the second normal form. Do the second normal form, you have to validate whether the table meets third normal form. Third normal form is a non-key column identifies another non-key column. So, you eliminate that third normal form violation, you would get a group of tables. Once you get a group of tables, you need to apply your validation principles to ensure there are no anomalies. What are anomalies? It deletes. So you insert a row, you can delete a row, you can impacting other rows of information. The table that shows your tables are meeting third normal form. This is in a nutshell normalization, and normalization will be heavily tested for the exam. So I just went through the process. I explained you in 20 minutes the chapter 6. Now I'm opening it up. Do you go over one more time or are you clear? I don't know who are doing. Who is in the background? They are killing the class. Okay, it's stopped. As people respect others, I really don't know why. Okay. So, is that clear, or do you want me to go over one more time? You can send me a chat message. Or if you unmute, I can unmute and okay, I muted everyone. Any questions, you can talk on the speaker or you can type chat window. If you're talking, please mute your phone, please. You go one. Okay. See, I'm just telling you, it will be more than 50% of your exam. The first part of the midterm or the midterm exam, the chapters, the first two chapters are basic fundamentals. You will get some type of questions, 4-5 questions. There will be more on chapter 6, the questions on ER diagrams. Then you will have some questions on the keys. Those are the things which will be. Finally, for the part B, I will give you some scenarios. Hey, see if this tail is normalized or not. If it is normalized, please go ahead and do the normalized. If you feel it is normalized, you can just erase. If it is normalized, you have to do the normalization. And how would you do? Take the 10 steps what I have given. Keep the document printed handy. Go one step over. Compare what I have provided. Compare the textbook, and if you are close, you score. So that please don't take the exam easy. It is going to be very challenging, and it will be tested in for understanding of the concept. No, you can do anyway, Sherry, the dependency diagram. I'm just showing you a method how to do. It is just nothing but it is called as a functional dependencies. So one identifies another item that's called as a functional dependency. So for example, I give a zip code 20904 identifies silver spring. So when it identifies Silver Spring, that means 20904 is functionally dependent on the zip code. So that becomes a functional dependency. So that is how you create the diagrams. I'm open to do whatever. How do I get audio from computer and not the phone? I really do not know. I think you have to switch on your microphone or speaker. POs. Speak, but I have been muted. Okay. Any other questions? I know. That is the reason I'm just muting the phone. See, you have to respect other students. You have to respect. We are all joining to understand a concept. We need to know. Is it wise to do this? That's all. Okay. Let me go one more time. Simpler, easy way. So when there is a question about normalization, so you print this, or you can use what Ellen has posted. Either way is fine. I just simplified into the steps. So there are 11 steps. If you can follow each step, the first ever table I give you, make sure there are no anomalies. If there are anomalies, then it is violation of normalization. Then any anomaly, any one, it violates. Then look for repeating groups. If there are repeating groups, it violates the first normal form. Then eliminate to get the table meet the first normal form. Then create your functional dependency list. Once you get the functional dependency list or functional dependency diagram, you get functional dependency list. Each list becomes a table. Then test your concept for the second normal form. If it violates the second normal form, eliminate that functional dependency list and keep remaining list, which becomes a table. Then when you go to third normal form, apply the third normal form concept. Non-key identifies another non-key. There is a violation of the third normal form. If you look at my example, the course number identifies course description, and both are non-key columns, but they are in the second dependency list. So if we take that dependency list, then break it into further into two tables. when you break to two tables, the concept of ER entity relationship, it should give the original table back. How it can create an original table? You need to have a foreign key. So when I break the table into two different tables, then I'm joining it with a course number. That is how you need to join back. So those tables, after you break it up, you test the third normal form. The non-key identifies another non-key is not existing because course number becomes a primary key and course number identifies course description. Once you have created all the tables and eliminated the violation of the third normal form, you can stop it. So because you need to go only up to third normal form for the exam. Once you come to the third normal form, the last step is test for any anomalies. That's what I said. Test the table to verify there are no anomalies. If there are no anomalies, then your tables meet the third normal form definition. That's it. Now, one problem would be, it would be about 20 or 25 points. So read your chapter and then make sure you understand what is being asked. Keep this handy and go one step at a time, and I will make sure if you follow it, and if there are minor, I would definitely consider for the work that you have done. Okay? Any other questions? From the normalization problem, do you want to see an evaluation from? Yes, James. Absolutely, yes. One question was there. Aaron had asked me, I would like to more focus on primary and foreign key constraint on how to input them into SQL program and also how to take first normal. See, I explained the second part of the question, and I really don't know all the features of ERD software. You don't need to be concerned about that. That is mainly for the lab project, and you are more than happy to send an email to Aina or me. We will be able to help you with the diagram. Now, focus of the primary key and foreign key, it's simple. There are two concepts I have explained in my first webcast. There are two into relationships. You need to understand entity integrity and referential integrity. Entity means a table. In order to have sanctity in a table, we need to create primary keys so that the data does not get corrupted. So, for example, a student table which has student ID and student name. So, if there are no keys, so student number 1 can be John, student number 1 can be Pius. So, now when you set the data from there, you do not know whether student 1 belongs to Pius or student 1 belongs to John. So, that it has lost its integrity. So, in order to restore integrity or maintain integrity, you need a primary key. Here, you create a primary key on student ID. Why can't you create a primary key on name? Because names can be common. You should not create primary key on the name. That is how primary keys are identified and created. Now, consider two tables, student and a course. One can take 0 or more courses. The student is related to the course table by means of a relationship. In order to establish the relationship, one of the table should borrow a key as a foreign key into their table. That establishes relationship between these two tables. When you have an established relationship, then it would enforce referential integrity. What is referential integrity? For example, in my case, student can enroll into 0 or more courses. That means student is connected to the course table. So when the student goes and enrolls into the course, it makes sure the course is existing and valid in the course table before the student can enroll. So this is enforced by referential integrity. So this is enforced by the referential integrity, which is the foreign key. So when you do that, your table becomes, the data becomes clean and there is no corruption of the data. That is how you have maintained your referential integrity. So this referential integrity enforcing is through foreign key. There's one thing called candidate key. Candidate keys are nothing but when you have combination key. In my example, student ID, student name, and city. We have student ID and student name. Imagine they are created as keys for the table. They maintain integrity or they maintain uniqueness in the table. Now, imagine you drop the key on student name. Drop the key on student name. The uniqueness of the values in the table is lost. When the uniqueness is lost, by virtue of which column, that column is called as the candidate key. In our example, student ID, student name, student city, initially we had student ID and student name as key. Now, we drop the key on student name. When we drop the key on student name, the uniqueness of the table is lost. The column or the key which is dropped, which causes the losing of the uniqueness, that key is called as candidate key in simple English, what I'm trying to give you. Okay? So I'm just answering Aaron's question on the webcast. I did not see any other questions posted. I have asked everyone to post their questions. There is nothing. Yes, go ahead. What is your question? So I told you, right? Anomalies means there are three anomalies: insert, delete, update. So I show you, right, the first example. Go back here. Okay. This is a big table. Okay. Now, in this table, if you want to insert a value for S3, S3 is a student. So if you want to enter a row of information for student, I cannot just put the student ID. I need to know what course the student is taking. That means beyond their values you need for the student. In a simple English, your business stops because unless the student takes a course, you cannot insert them into your student table, which is the violation of insertion anomaly. You cannot insert with minimal rows or minimum columns. That is called as insertion anomaly. In an example or in the table, if you look at S1 and S1 has 2 rows, S2 has 2 rows. If you want to delete S1, you cannot say delete from student table where value is equal to, where student SSN is equal to S1. It will delete 2 rows. It needs to identify other columns in order to make sure you do not delete incorrect row. So that is called as deletion anomaly. And same way when you want to update, there are more keys are needed or more columns needed to identify specific row of information in order to update. That is called as update anomaly. If you have any anomaly, that means you are running into normalization issues. Okay, so first you have to eliminate repeating groups that will meet you into first normal form. Before going to second normal form, you have to create functional dependency diagram. Then you have to come up with your functional dependency list. Okay, functional dependency diagram will give you functional dependency list. This functional dependency list are nothing but 4 different tables. Now, you have to apply the violation concepts or test for the second normal form. In our example, non-key column depends on all candidate keys, not a subset of candidate key. If you look for that violation, course number is identifies course description. Here, one non-key identifies another non-key. So, it should not be a subset of a candidate keys. That comes a violation here. So, you need to eliminate that functional dependency list in order to create your tables. So, from this list, you come out with these 3 tables. So, eliminating this one. The yellow one is eliminated. Okay. Eliminated because violation of second normal form. Okay. Then you have third normal form. If a non-key column identifies another non-key, it is a violation. So we have to see where there is violation. Here course number identifies course description. That is a violation. So we take that table or that list and put it into 2 tables. That is what I have shown here. Okay. You create this table, you create this table. When you created 2 tables from this main table, you should be able to join back to get your original table. How you join? You join with this course number as a foreign key in this offer number table. Then the 2 tables can be joined to create your big or the original offer number table. Once you create this one, your tables are in third normal form. Then you have to validate there are no insert, delete, update anomalies. If there are no